Hi, my name is Mahmoud Yaman Sirajuddin, and today I'll be presenting the video for assignment 4 for the advanced machine learning course. Okay, so we have three files, three parts. Okay, so we have the name, the mount drive, okay, package installations, imports, and then some helper functions that were already provided, more helper functions. Okay, so now we plot the data and we see that we have the images of flowers and their contour, basically there. So we have to make a model that detects the edges of flowers essentially. Okay, so we load a pre-trained model, which is the DeepLab version 3, of which is the ResNet. Okay, and then we have these helper functions, okay, that were provided. Okay, so the first thing that we had to do was basically freeze the last layer. So we were told that the last layer is classifier.4. Okay, so all we had to do was to iterate over the weights to iterate over the weights of the model, all the weights, and then those that had that basically started with the classifier.4, so they were in the last layer, they were appended to the list of learned parameters. Okay, all this code was provided previously, so we're essentially training the model. Okay, and then in the second question we have to freeze the layers. Okay, so first we handle the device. So if we have a CUDA GPU, we use, if we have a CUDA capable GPU, we use CUDA, otherwise we use a CPU. Okay, and then the model, the fourth layer, which is the last layer, we create a 2D convolution layer with kernel size 1. Okay, and okay, the same number of in channels. And then for the parameters in the model, so these are the layers that these are not the final layers. We basically freeze them and then we unfreeze the last layer. Okay, and then we just move the model to the device that we're using. Okay, if it's CUDA, we move the model to the we move the weights to the GPU. Okay, and then here we have the tests. Okay, the predictions. So as we can see, we have the flower. This is the yeah, actually now I remember why we used it too. So essentially this was for separating the foreground and the background. Okay, anyway, so this is for the foreground, if I'm not mistaken. If yes, it's for the foreground. And then here we have the edge of the flower. Okay, and as we can see from these examples, the predictions are pretty good. Okay, so we have more predictions and the predictions are working great. Okay, now I have to compute the intersection over union loss. So to do that, first we compute the softmax over the prediction, and then we take the essentially we take the foreground. Okay, we compute the intersection and then we compute the sum, and then like we get the loss essentially. So this is just a standard equation. And here, so what do we have? So the classifiers. So now we're yeah, we're just essentially doing the same thing. How, yeah, we were just repeating the same thing that we did earlier to the other model. Okay, and then we do the predictions, and as we can see, it's working pretty good. Okay, and that's it for part 1. Now for part 2, what we have is essentially face recognition. Okay, so same thing, imports helper functions. Here we have Kirby. Okay, so we have like two similar images, and then one that is completely different. Two similar, one that's completely different. Okay, so first, in order to calculate the positive negative embedding, we just take the square root of the anchor minus the positive, then the square root of the anchor minus the negative over the columns, and then we return them. Okay, so this code is already provided. Talk about nothing. Here we are taking the anchor, the positive, the negative, and then we're separating the targets. We don't need them. Okay, and then we're taking the AP distance and the AN distance, so the positive and the negative, from the Siamese network that we already have. And then here we're calculating the loss based on these formulas. Okay, these were already provided. Then we train the model. As we can see, the final loss at epoch 29 is around 7%, which is great. We save the model, we load the model, and then we load the data set. Then we just perform a bunch of tests. Okay, so we test the model and we see that it's working pretty good. Okay, so yeah, so given these two examples, the model is working decently. As for part 3, which is the style transfer, okay, we have the same thing, helpers. Okay, so here, where is it? We have, okay, so we create a zero tensor, okay, to calculate the loss, and then we iterate over the features, the targets, and the weights. If the weight is 0, I mean, we don't have to use this. I just used it because I was afraid it could cause some issues here. So just like if it's 0, just ignore it, but it would be the same thing. So we don't do useless assignments. So it would be loss equal to loss. I mean, which is, doesn't matter. There is no difference. Okay, and then we calculate it based on the mean square error loss. Just give it this, and then we multiply it by the weight, then we add this, and then we return. Okay, as for the style loss, we do the same thing. However, this time we use a gram matrix and to obtain the gram inputs and the gram targets, and then we feed these values into the mean squared error function, and we get back the same result. Okay, so now we train the model, and then we essentially, given two images, we apply the styles, and we're done. So yeah, this assignment was it was easy. It was guided mostly. We didn't have to do a lot of work. So yeah, it was convenient. Thank you for watching. Bye.